Yeah, okay. Guys, how many of you have seen matrices before, studied matrices before, or or you have some familiarity with matrices? Can can any of you tell us what do you think when you see this uh, notation with these numbers written inside these brackets? What does this mean to you? Can any of you tell us? Hmm? What does it remind you of? That is the first question. So what does this remind you of? Or you can type in the chat if you are not in a setting where you can unmute yourself. You can type in the chat box also. Yeah, numbers arranged in a row and columns type. What else? What else do you think of when you see a matrix?
You can
Type
sort
of
of
algebra.
represent you
Mm-hmm.
can sort of represent a problem in sort of a tabular form.
Right, right. A function. Yeah, perfect. Nice. What else? What else can do you guys?
Anyone else? We are writing it down.
Yeah.
What comes to your mind when you see a matrix? I mean to say matrices.
So some people have said a function. Some Rishabh has said type of algebra. Some people have said numbers arranged in row and column. What else do you guys? What else do you guys think of when you see a matrix?
Someone actually said collection of vectors.
Ah, right, perfect. Yeah, that is nice. A collection of vectors. That is nice. Yeah, a collection of vectors. Anything else?
How many of you agree on that matrices well can represent a system of linear equations?
Yeah. How many of you agree with that? Or if you want to counter that, you can counter that as well.
Okay.
Yeah,
Okay,
there's
so
a
two people
lot of
agree.
people responding in the chat also.
Yeah, I'm looking at those as well. So three people agree. Okay, four, five people agree. Nice to see more hands. Okay. So do you guys think of anything else when you see matrices? Perhaps a linear combination of sorts. Anyone? Linear combination, does that ring a bell? No?
So I guess the ones who are raising their hand agree with the fact that it represents a linear combination.
No, I hope so.
If not, so please lower your hand.
Yeah, right. So if it's a linear combination, then what is it a linear combination of? What is it a okay?
There's some noise.
Muted then. Muted. Okay. So yeah. If you guys think of it as a linear combination, then what is it a linear combination of? Anyone? You can type in the chat box. It's okay. If you're not comfortable speaking, that's perfectly fine with us. You can type in the chat box. I'm sure you guys can do that. Columns of this matrix. 2 by 2 right. Oh, right.
What is that?
Yeah, right. Columns
Columns of
of this 2 by 2 matrix.
linear
And
combination of columns of this 2 by 2 matrix. Okay.
Yeah. Do all of you agree that it's the matrix can be thought of as a linear combination of columns of a 2 cross 2 matrix? What do these columns even represent? Guys, anyone? What do these columns even represent? I mean, Janendra talked about that it's a linear combination of columns of a 2 cross 2 matrix, but what do those columns represent? What do they mean? What's the significance of those columns?
Actually, you need the input to represent it as a linear combination, right? With just the matrix, can you represent it as linear combination?
No, if you take a linear combination of this with 1001, eigenvectors. Okay.
Somebody is saying eigenvectors.
Yeah, Rishabh is saying that. No, not eigenvectors. Basis vectors. Where I cap and J cap go. Yeah, right. That is right. Where I cap and J cap go. Correct. So those
New I cap.
yeah, right. So those column vectors, they contain the information necessary to tell us where the I cap and J cap will go, right? Where they will get mapped to. That is right. So do all of you agree with these 5 points that when we see a matrix, a vector in 2 dimension, okay, yeah, right, okay. So do you all of you agree with these 5 points, or if any one of you disagrees, you can tell us that as well. You can counter these 5 points. Anyone?
So let us make them ask them to raise their hands. How many of you agree that? How many of you can you defend the fact that matrices represent a function?
Yeah, just raise your hands. How many of you
Can defend this fact?
Yeah, right. Okay, perfect. Okay, who else is there?
8, 9.
Guys, 39 out of 39, 38 people is okay, 12, 13, okay, 14, okay. More number of hands. Okay, perfect. Right. We would like to see some more hands. There are 38 people in the.
And the rest of them do not agree, na?
Oh, right. Okay.
We will ask them to raise their hands.
Okay.
The ones who do not, all of you let us down, lower your hands, and
Yeah.
the ones who do not agree, raise your hands, please.
Right. Please raise your hands who cannot understand why a matrix can be thought of as a function. Just raise your hands. Anyone else apart from Sneha who does not know why we wrote that point that we can think of a matrix? Shreya as well. Okay. Vignesh, perfect. Okay. Anyone else? Guys.
Actually, I raised my hand earlier also, but upon thinking, I actually got confused because if you look at a function, for example, for a 2 by 2 matrix, you have, for example, fx equals to y plus 2x. Okay. So you have a y and you have an x. So that's represented in the first two columns. But what about the second row?
Nice. Nice, we'll come to it as well.
Yeah, just
Yeah, go ahead, Maria.
when you think of f of x equal to y plus 2x, like what's your domain and codomain?
And is it a function in one variable? That's also another question.
It's
I guess
fx. Yeah, if it's
I guess we are beginning to enter into our second question, you know. So Chetan, should we enter our second question or just deliberate on the three
No,
sub
no, no.
questions that are
First,
altogether?
let us see why do people even agree with these 5 points? Then we'll jump to the next question.
Okay, okay.
like who can the person who actually said f of x y equal to y plus 2x just like what's the domain and codomain for this function?
Okay, is your function in a single variable? That's what I'm asking you. Is it a function in single variable? You
Because the
wrote
person
f of
went
x.
missing a bit, like whoever that
You
was.
wrote f of x equals to y plus 2x, right?
I
So
think
is
it
it a
should be
function?
f of x y equal to y plus 2x. Then like
Exactly. Yeah, that's what I'm asking. Is it a function in one variable?
yeah.
Do you know what y means? I have the same question. I have the same question. So is y a constant? If it's a constant, then
Yep.
yeah,
Yep.
maybe you can.
Yep.
Shreya was it right?
Yeah, it was me.
So when you said f of x equals to y plus 2x, did you mean a function in one variable or a function in two variables?
No, two variables. My
Right.
bad. I actually said it wrongly.
She meant this one.
Yeah, right. So f of x equals to y plus
Yeah,
2x. Yeah.
okay. So do you think yeah, so what's your domain and codomain? Just think about that.
Perfect
Uh,
question.
You're
No, it's
inputting a pair of numbers, right? So what's your domain in?
Correct.
but domain and codomain is not related, right? Because I
It's
mean,
okay. Okay. Yeah. You're right. So we haven't established the fact that we can consider a matrix as a function. We'll come to that as well. So yeah, let's first discuss the fact that why we can consider a matrix as a function. Okay, let's write down a matrix 1, 2, 3, 4.
there it is. A is
And
equal to 1, 2, 3, 4. It is already
right,
mentioned.
right. But scroll down a bit, Nishan. Scroll down a bit, and let's write down. Okay, extend this page. Yeah, so that we can write.
And we must take
Okay.
a screenshot of it afterwards. Fine. So that
Okay,
I
no
will.
issues, no issues,
Hmm.
no issues, no issues. We'll do that. We'll do that. But open it. Zoom in. Yeah, write a matrix 1, 2, 3, 4. Okay. Write a column
Okay.
vector. Mhm. Yeah, go ahead.
Mhm.
Yeah, so when you like we just try to think of a matrix as a function. So what's the basic definition of a function that we're all familiar with? If someone could unmute
Yeah, perfect. Perfect.
and say that. Like what are the two things that you could think of when you think of it as a function?
Takes a set of inputs and gives an output.
Yeah,
Perfect. That's right. So you take some input and the function gives you an output, right? So yeah. So if I multiply this matrix with some column vector, say 1 comma 2, can anyone tell me what the multiplication or what the result would be?
Multiplied with Chetan.
Column vector 1 comma 2.
one comment.
Can any one of you type in the chat box, unmute yourselves?
It
Tell
would
me.
be 9 and 11.
Okay, think again.
the first one will be 5.
Yeah, right.
Second is 11.
Correct. Perfect. So you multiply two matrices, column placement, 5 comma 11. Yeah, perfect. So 5 comma 11. How did we get this 5 comma 11? We simply multiplied these two matrices. We have a 2 cross 2 matrix and another 2 cross 1 matrix. We multiplied 1 into 1 plus 2 into 2, that is 5. That is our first entry in the 2 cross 1 matrix. Then 3 into 1 plus 4 into 2, that is 11. That is our second entry in the 2 cross 1 matrix. Okay, so we have a matrix with two entries, 5 comma 11. Perfect.
No, 1 second, 1 second.
Hmm.
The ones who said that, matrices could be thought of as a function,
Hmm.
why do they think so? Let us ask this
Yeah,
question
right.
one
Right.
by one. Everyone, let us tell us, share with us.
Why do you think?
Why do you
say-
think matrices are functions? Functions, why?
Okay, perfect. Guys, anyone, you
What is
can
the
mute
motivation?
yourself, type in the chat. We are looking at the chat box. We are hearing you guys.
Someone
Anything.
actually said, like, it was a really good answer that you can think of a function, you need some input and some output. So maybe we can ask the question, like, we're just saying that a matrix is some sort of function.
Right.
So, like, obvious question that might come into our minds is what is the input, what is the output?
Yeah,
correct.
maybe someone who said that they can think of it as function, they can unmute and answer it. Guys, I saw a lot of hands.
Yeah,
Uh,
it would be preferred if it's someone who hasn't been to the session before, because this is actually really interesting once
Yeah,
you
I see new
understand
people
it.
in the session. I see new people in the session.
maybe, for example, in the same example,
Oct9, sir is asking us to cover some of
Mhm.
the 75 questions from the
This
linear.
is the first one. This is the first one.
Yeah, sure.
Okay,
uh,
guys. Yeah, go ahead.
for example, in the same example, we are
Yeah.
taking this second vector 1, 2,
Perfect.
and we are applying a matrix. For example, we are multiplying that second matrix, and we are sort of mapping it or getting an output.
Correct. Correct.
5 and 11.
Right. So if I give it another input, say 2 comma 1,
It
another
will,
in. Mhm.
it will be mapped to like a different output will be given.
Yeah. So what will be the output?
4 and 6
Mhm.
and 10, 10, 4 and 10, I guess.
Yeah, 4 and 10. Perfect. So we gave it an input, it gave us an output, right? So this matrix contains some information that transforms our input to some output. Do all of you agree with that? The
Uh,
new people who are new to the session, okay, one person has agreed. Shreya has agreed. Okay. Okay, Kashif has agreed as well. Okay, others do not agree with this. They don't think of this as a function.
Someone
Okay.
has, Anshuman has raised his hand.
Yeah, go ahead.
no.
Okay. So yeah. So now can we see that we took a matrix, we gave it an input, we got some output. That was the basic definition of the function, right? A function must take some input and give us some output. So is this matrix working as a function? Can we say that? Or someone would like to counter that? Someone has some different opinion about it.
I guess, for example, in that horizontal parabola, we for the same input we get two different outputs. We might have to check that. For example, if we are giving a column, that would be satisfied. Yeah.
Yeah, I don't
Yeah.
know what a horizontal parabola is.
I mean that y square
Yeah,
equal to 4.
we'll come to it. We'll come to it. That's the second question. We'll come to it. So matrix
Okay.
is like F, where F of 2 comma 1 is 4 comma 10. Yeah, that is right. Correct. That is right. So we have a matrix as a function. So all of you can see it as a function, right? So okay, someone might say that why we are even considering this as a
Okay,
function.
okay. Something that I found out, like, okay, generally when we write the function, do we write 1, 2, 5, 11, or do we write it in some other way? Like, what are we
So do
actually
you,
familiar with? Like, when we write a
Mhm.
function, do we write 1, 2, 2, and like, didn't someone think of it in that way?
Guys,
We write function in this kind of fashion, isn't it? F of
correct.
something is equal
yeah,
to some.
So
F of
yeah,
some
so
input is equal to
yeah,
yeah,
some.
what is that something we usually used to didn't use?
like
Like
a
someone said
variable,
f of
like x, some variable.
xy is equal to y plus 2x. So
Right,
yeah,
right.
yeah, it's a
So isn't this a representation where we give it a f of input and equals to some output, right?
Yeah,
Function quotation, right, right. So we can
So
see. Mhm.
somebody was
mm,
saying now there was one guy who said that it is not representative of a function. So is it clear to that person that matrices could well be a function?
Right.
Who was that? I forgot.
I think it was me.
Ah, yes, sure. So can you see that now matrices as a function?
Yeah, I think it makes sense. I think
Right.
when you were talking about codomain and domain, were
Mhm.
you referring to like function being valid if there's one to one or many to
No,
one,
no,
but not
we
being
aren't
valid?
even we
we,
aren't
we
even
aren't
coming.
thinking of that.
Right. We haven't
Like
discussed that question.
maybe this thing about, since you asked that, like you mentioned a function f of xy equal to y plus 2x.
Yeah,
Then we said that a equal to 1, 2, 3, 4 is a function. Maybe,
yeah.
what do you think? Like, is there some difference you notice? Like you said, both of these are functions, but what's the difference? Maybe you noticed.
Like there's another dimension to the
Yeah,
matrix.
correct. Yeah, that's what I also thought. So, so there's also one other dimension to the output. So, now, what do you think is the good place where the set of inputs belong to?
I didn't get
Mm,
the question.
Like,
yeah.
what? So,
Mhm.
yeah, so you said the in like when we represented metrics as a function, there's an extra dimension. So, like maybe if that's the difference, right? Yeah, that's correct. Like, let's just leave it at that. Yeah, yeah, that's the actually the correct answer. Like, that's the difference between both of them. Like, in other terms, you can say that our first function has a both the domains are the same. Can you notice that? Like, we are feeding in two variables, right?
We are feeding in
Yeah.
2 points, two points
We
on
are
some
feeding in an
plane,
ordered pair, to be precise, right?
Yes, yes, yes.
And in
right?
one case, what are we actually getting?
Okay. So we are giving it input of two numbers, an ordered pair of two numbers, or a point. How do we represent a point? Where do we represent a point? What should be our input? If we have our input as a point, an ordered pair, how do you represent? Where do you represent an ordered pair?
Partition
uh,
plane.
in a plane.
Yeah, right. A plane, an R2, right?
Yeah, yeah.
Right. So that is our codomain. Sorry, that is our domain here. R2. And our codomain would be, so what is the output you are getting? You gave it an input. You gave it an input of ordered pair. What is the output you
That's
are
also
getting?
R2. That's
Yeah,
also
that is
R2.
also R2. Right, right. Perfect. So we can think of matrix as a function where we give it an ordered pair, it gives us an ordered pair as well. It returns us an ordered pair. So a function whose domain is in R2 and whose codomain also lies in R2. Correct? Clear, everyone? Okay.
So I guess we are done with this function thing. Fine. They're clear that there is input to it and there is output to it.
Right. So the next
We
question
can, yeah,
that
we
comes
can
is,
also,
Mhm.
just last thing, like before we move, like we can also visualize it like this way. So I got a good analogy in that, like we all might have seen the movie Three Idiots, right? In that we got one character called Virus, who
Right.
has the unique ability to write with both the hands,
Yeah.
right? So if we imagine two Cartesian planes side by side, on one side there is a circle drawn or some point, let's say 1 2 or 2 1 is there, and at the same time the person, that Virus, is trying to plot that same exact that point in that new transformed plane. So that way also we can try to assume like what matrix is doing, like he is computing the matrix product in his head and is trying to find the new point which is there in the new Cartesian plane, and along
Wonderful.
at the same time he's trying to plot both the things. So that can
Virus,
also be taken.
That's
vi-
actually really nice. Yeah.
Yeah, that's a wonderful idea, right?
Virus himself was a matrix.
Yeah, Virus himself is a matrix. Yeah.
Okay. So the next question that arises, now that we have understood that we can think of matrix as a function, the next question arises, why do we use a matrix? And what are the applications of matrices? Why do we even think of matrix as a function?
Or maybe someone can tell us, like, what's the first time you actually learned about a matrix? Like, why do you think, like, what was the way you were introduced to
Oh,
it?
right.
Then maybe, like, I think I learned this in eighth or like probably properly in maybe 12th, I don't know. But
Mhm.
then someone just
Yeah.
told me you can just write data points as rows, columns, right? I guess that's the way we've learned of matrices initially.
Yeah.
And then maybe one application that we use matrices for, like, what's that application that a lot of us are pretty familiar with?
Where did you first see the matrix?
Like it had something to do with solvings. Like
Mhm.
yeah, cross product of vectors was also there, but solving simultaneous equation was also.
Right. Perfect. That is right.
I
So
guess
that's
before matrices we were introduced to vectors, right?
Yeah.
And then we somehow knew that someone actually said collection of vectors. So, like, can you be more precise? Like, what sort of vectors? Like, when you say vectors, what are the kinds of vectors you generally say?
physics. Cross product of vectors. Okay. Right.
Yeah, I guess we came to vectors, then somehow we knew that the collection of vectors was matrices, which is like
Yeah.
kind of
But the
valid.
idea of matrices came from the uh, system of linear equations, simultaneous equations, right? When that's where the idea of matrices came from.
So, this is even though we were introduced to it as vectors or a collection of vectors, people actually started using matrices when they needed to solve a system of linear equations. So, whenever you think of matrices, another thing that should come to your mind is a system of linear equations. We don't know the number of variables. We don't
Simultaneous
know.
equations. Right.
Yeah.
Right. So that's why we use matrices. That's why we are even discussing matrices. Okay, we can use matrices to solve simultaneous equations, system of linear equations, and I'm sure some of you can also
Maybe
mention what
Chetan, you
are.
can write some example, like just maybe a small example where you have like everyone has an idea what they mean when they say system of linear equations, right? I guess the
Okay,
term is
can you write two equations, Nishan? We'll break those down. So 2x plus 4y equals to 8, and x minus 3y
We just write down the
equals to 12.
system of linear equations in
Yeah.
Becker's problem.
12.
So, fine.
Okay. Yeah. So can anyone tell me how can we represent these as matrices? Anyone? How can we think of these as? Mhm.
We can, like, in the first row it will be 2 and 4, and in the second row it will be 1 minus 3
Perfect. Perfect.
multiplied by x and below y,
Right. A column vector containing x and y. Right.
exactly, and equals 8 and 12 under it.
Yeah.
Perfect. 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 Okay. So can you guys see why we call it a system of linear equations? So we had linear equations, and Sneha here told us how to write those in as matrices. Can you all see that we have just written down these two equations as matrices? Can you all agree with this?
Yeah.
Or do you guys not see why we can write these as two matrices?
No,
Anyone?
no. A caveat, a caveat. Do not ponder on what is the solution of these two equations.
Yeah,
How
forget
do
about
we,
solution.
what properties of matrices are we going to use to solve this? Just focus on this thing, that can we represent or not?
Correct. Yeah.
A very simple thing. What we have done, we have removed x and y and written the coefficients in a matrix. Fine. And there is of course a variable x, and then the right hand side matrix we have written as on the right hand side.
Right. So if we multiply these two matrices,
there is a
that-
pattern, of course,
Mhm.
between the system of linear equations and matrix. I mean, we can interchangeably use both of them.
Right. Nishan, can you expand this page?
This page is already expanded, I guess.
Okay, this is already expanded. Okay.
Maybe I'll share the screenshot now, and afterwards I'll.
Yeah. Do you want me to take over? I have
Yeah.
board.
Lifesaver.
Yeah, sure.
Yeah. And I have another app which is very easy to use. Maybe you can download that if you want to take notes also.
Right. Okay, let me order it back on tablet myself.
Yeah. Okay. So is everything done here? Anything? that needs to be discussed?
We were just trying to explain why we can write these as matrices. Why we can write two equations as matrices.
Okay.
Yeah. That's what we were going to do it. Shriram, we were about to discuss that.
So can everyone see my screen?
Rishab's actually asked a question. Like, I think that's also something we need to discuss. Like, is x square plus y cube equal to 0, a
Rishabh.
system of linear equations?
Right. Rishabh has asked a question that is x square plus y cube equals to 0 is a system of linear equations.
Okay, we'll go step by step now.
Yeah.
Maybe if we go through questions one by one, we'll be able to maybe clarify the doubts when the time comes.
Yeah.
Okay, awesome. Let me just share the question. Where are we currently?
So we were discussing how and why we can represent two linear equations as matrices. That was
You're in the first question.
Awesome. Okay, it's first question. Okay. Sorry for taking time to catch up. Okay, so
you can write two linear equations and a matrix representing those two linear equations.
Okay, can you give me any two linear equations?
Yeah, 2x plus 3y equals to 8.
I think we can ask someone from the audience to suggest that, because just to make it more lively.
Yeah, go ahead. Guys,
Like,
anyone?
I think Shreya was one of those people who was saying a lot of answers. Maybe you can go ahead.
Shreya, Sneha, anyone?
So another equation, right?
Yeah, another equation.
Okay, 3x
Perfect.
minus 8y equals to 11.
Okay. So what would be the matrix representation of this equation, these two equations?
2, 3, 3 minus 8.
Perfect.
Matrix form would be 2, 3, 3 minus 8. Okay.
Multiplied by x, y
Yeah.
equals 8, 11.
Awesome. So we're able to represent this set of linear equations, right? So this is set of linear equations, and we're able to represent it as a matrix. Awesome. Okay. Why does it help it? Maybe that will come as we go. But we know that we're able to represent it like this. And yeah, so we're able to look at a matrix as something that can fit in where there are set of linear equations, right? I just want to focus on where all can I use this matrix, right? Okay. Anything else from the first question we want to discuss? What does it denote? So I think there were a few points that everyone had talked about, right? So we looked at it as a
In the
function.
PDF, there was a
Yeah.
point where we mentioned linear combination of.
Yeah,
Okay.
we'll come to that as well.
Yeah.
We haven't discussed that. We haven't discussed column picture as of here.
Yeah.
So we'll come to that as well.
Yeah. Okay. So maybe to understand how it is a linear set of, I mean, how it is a linear combination. First, we want to define what a linear combination is, right?
Right.
But let's say we'll get to the syntax, right? So after a few questions, is that okay?
Yeah.
Okay, so we know that I mean, it kind of represents a linear combination, but let's say we will tackle it when the time comes, right? Okay. Anything else that was mentioned by the?
Yeah. So we were going to ask people that if they can enlist some examples or some applications of matrices, and why do we even use matrices? So that was the question.
Okay, so where and why do we use a matrix, right?
Right.
Yeah. Good. Okay, go ahead. So is this one of the uses? Can we think of this as one of the uses?
Yes.
One of the uses. Not just representing,
Yeah.
but once we represent, we can use this representation to help solve. Okay.
Right.
Right.
Do you guys all agree with this?
I mean,
Yeah.
we would like to represent it, and I mean, there should be some pro of representing it, right? We want to represent it, and maybe, you know, it can not it can help us. I mean, the same way
There
we
should
solve
be
this.
some use, right? There should be some use. If we are going through all this trouble to represent two linear equations as matrices, there should be some use of it. So can we use this to solve this x and y, solve for these x and y's? Do you guys all agree with that? Okay.
Yes.
2 thumbs up. That's nice. All others don't agree. Okay. No issues.
Is it?
Four, no. I just saw 3 thumbs up, right? So I was just, yeah. So okay.
let us
So if
let us more appropriate this statement. So it is very obvious that there are two equations, there are two variables. We are very what is coming to our mind, very obvious thing is that, come on, why are you doing this? Why are you writing a new concept? Why are you using matrices?
exactly.
Fine. I have been doing this, I've been solving this since time I don't remember. And why this? Why do this? Why write it as a matrix and all? Why use a new notation?
Yeah, can
So-
someone say like I don't know matrices, so what would be the default way I just go about
correct.
solving this? Like someone
Yeah.
just
Default way.
Yeah.
Yeah. Okay.
That is a new topic to discuss. What is a default way? Anyways, so what happens that this is called confirmation bias. What do we learn first? We think that is the only the right thing. Anyways, let us not go on this such things. So the thing is that I'll ask everybody to give a thumbs up if they agree with me. So what if there are more equations and there are more variables? Could you solve with same level of same speed? Would you consume same amount of time and solve if I go on increasing number of equations and number of variables? Will it be feasible for you? Can you still will you still be thinking, okay, this is such a trivial thing, why are we discussing it?
Correct.
And if I tell you, okay, I know a method, what was that term used? What did she that
First
Maria, you were
principles.
not first principle, what this somebody said that
Default.
no, what would be the basic approach?
Yeah.
So would you
Default.
still a default approach? So do you still think you should apply a default approach, or
I mean, the high school method intuitively would be subtracting these two equations or substituting the values, right? That would be the high school way of doing it, right?
Yeah.
That's how we come to how we solve x and y. That's how we do it, right?
Yeah.
Substitution
Yeah.
and subtraction. Okay, now perfect. Now we have two equations. We can do that. But what
So
if I give you 30 equations?
so if I tell you that by representing this system of linear equation with 30 equations, 30 variables, I can tell you that I know a way how to solve for x and y given any number of columns and any number of cores. We are okay with it now, with this now, that the linear equations can be well represented into a matrix. So if I tell you that I can tell you a way of solving this matrices, if I can tell you, so there is a way of solving for x and y given us matrix in the form x is equal to b. So would you still think like that, okay, why are we not going by basic approach?
Yeah.
Or you will adopt this as a basic approach itself?
Okay,
Right.
that's one question maybe someone can answer. We already know this approach. Why do you think we even need matrices? Like, we already know this approach works, obviously. You just have to subtract, multiply, add
Very valid question.
cancel the common terms. Like, why do you think you need matrices?
Yeah. Why do we need matrices?
Maybe Shreya or Sneha can try
Consider
this.
this,
Those are the two people who are kind of active here.
consider
Yeah.
this thing. Like in these equations, the right hand side is fixed. But if we wanted to find that from what are the possible right hand side of this equation that we can reach, which with do two equations, that standard that previous approach will not suffice. But through matrix approach, we are able to see that.
Right. Exactly.
Wait. I'm confused. What is that?
What I'm saying is like on the right hand side, the value are fixed like 8 and 11 here.
Mhm.
But if you want to see that from where the left from using only left hand side, what
Using
value
only matrix as the function where all we can reach.
Okay, isn't that the same thing as telling me
Linear
forget what
combination.
this is, forget what this is,
yeah.
and
Yeah.
just plug in different values of x, y?
Correct. Same thing.
Yeah, same thing. But
I mean, it doesn't. I mean, I don't think that is as an advantage of matrices, right? It's just
Yeah.
another way of representation.
That's it.
Can we go with inverse of a matrix procedure, like finding the adjoint?
Mm-hmm. Yeah, that's how we would solve
So
this.
so
no,
matrix representation gives us an alternate view. Like from here, we cannot means if the system like it is a 2D system. So if we go for this elimination or drawing a lines or so, intersection we can see easily. But if the number of variables increases like 2x plus 3y plus 4z equal to a constant, then this sort of system would be making a plane in three-dimensional space. But using the view of matrices as a linear combination, we are still able to clearly visualize the intersection, this solution point easily.
I would like to add a caveat to this discussion that we are having. We are here to solve 75 questions. 75 questions that would cover the complete linear algebra. So let us go step by step. Do not use the terms which we have not yet discussed. We are like just 10th standard pass through students, and we have to go by first approach. We are learning everything for the first time. Let us not use transpose and different jargons. Let us go step by step. If we are going to use something new, let us first define it, then start using it. Fine.
Okay.
Because these questions are designed in such a manner so that as we go along, we introduce new concepts and learn them and master them. So the question at our hand was that where and why do we use matrices? Fine.
Yeah.
So now we understand that why represent system of linear equations in form of matrices. We will eventually find out how to solve them. Do not focus on solving for x and y and all. Now we know the significance. Why? What is the edge we get? What is the profit we have? What is the profit we get by representing the system of linear equations in the form of matrices? We are at least clear with that, because not in every real life situation you will have only two two equations and two variables. That is just to introduce you, when we are learning for something for the first time, we are taught, okay, 1 + 1 = 2, but that does not mean that we all of our lives we are going to count 1 + 1 = 2 only. Eventually we generalize and make multiplication out of it. Okay, repeated addition is multiplication, and then division and everything in mathematics. So we are in that phase that we are going to kind of generalize this approach, how to solve system of linear equations. We are actually, I guess we are clear with this. If we are clear, please put your thumbs up if you have
So
understood.
let me know that you've understood.
We go to the next question. I think we discussed this, right?
We are done with this question, I guess. So the next question is, can you enlist a few applications of matrices? Applications of matrices. I guess we wrote that, no? System of linear equations on in MS Paint. We read that wrote that 7-point thing. Or should we rediscuss it? Few application of matrices.
Yeah, it's very similar to the previous question, right?
Very similar.
Right.
Let us go to the question number 2. Point.
Right. So
the-
what are go ahead.
So the question number 2 is define a function. We were just talking, matrices are functions. Fine. We understood there is input, there is output, and matrices are acting like a function. So before we move ahead, let us deliberate a bit on function. Our next few questions are only based on functions. It is a kind of revision. Let us go through it quickly. I guess most of us would be familiar with what are functions. Fine. So the next question is define a function. And the next part of it is what is surjective, what is injective, and what is bijective function. We'll go through it quickly. Anybody who can just define what is the function? Define a function. Anybody? Quickly. And we will, ask everybody to raise their thumb, do a thumbs up if, if they agree. Okay, somebody is asking that. Can someone, there you go. So define a function. Somebody, please unmute yourself and feel free to express yourself.
Right.
What is the function?
An equation which takes some inputs and gives an output.
Equation. An equation which takes an input and gives an output. Okay. Equation. Okay, how many of us agree with this statement? Or somebody has to counter with this? Counter this statement, somebody. Or somebody thinks that there is more appropriate definition of this, of a function. Let us indulge everybody, please. Equation thing.
Yeah.
Yeah, I
Can
think
we
we
always
can.
represent function as an equation?
Yes. Somebody was saying something.
Yeah, I think we can have anything in place of an equation, basically. Like something takes an input and gives us an output, a unique output, basically.
Okay, a kind of machine which takes an input and gives an output, huh?
Yeah. There can be anything.
I guess the keywords here is there is some input and it gives you some output.
Right.
Let's focus on that here.
Okay.
Yeah.
There are lots of answers in the chat too. There like
Can you
some
please read
rules
them?
describing a relation between two sets of
So
elements.
people are saying for every input, a unique output is given. Something that transforms any given input in a certain way is what Ajit is saying. Shady 3458 is saying a rule describing a relation between two sets of elements. Okay. Anshuman is saying, I guess it would be something operations on inputs to give a unique output. For every input, a single output. Yeah, right. It can be any black box that takes an input and gives an output as long as one unique input leads to one output. Okay. A function is a relation between a set of inputs and a set of permissible outputs with the property. Okay, the bookish definition, right? Okay, we have all sorts of definitions, right?
Correct. Again, I'd like to emphasize on one thing that here in Coders Eye, we do not use jargons.
Yeah, there are a
We
lot
have
of new
like
people here as well.
let us not focus on traditional way of saying. We will eventually agree to zero down on the facts, so that it stays with us rather just mug up the definitions. For example, many were mentioning of functions, relations, so that leads us to a completely different direction. That first of all we define relations and deliberate on relations and then come to function afterwards. We're directly dealing with functions. So anyways, a black box definition, that was really impressive. We do not know what it is, but it takes an input and gives an output.
Right.
Fine. Okay, so the next question is, what is surjective, injective, and bijective functions? We are done with functions. Of course, these are kinds of functions,
Right.
So what is surjective, injective, and bijective? Let us start with surjective function. Anybody? No, give a definition. Do not give a definition from internet or
There's
somebody.
actually someone has actually written in the chat, I think. Surjective.
Let us read it out. No?
I can't find it. I saw something.
They have deleted.
Yes. Okay, deleted. Somebody is saying that he wrote and deleted it. Anyways, let us define what is. Let us deliberate on surjective functions. What are surjective functions? Anybody? Unmute
A
yourself and
surjective
feel free to
function is one which has all the whose outputs are all available in the range. Means I mean all the all the values which are present in its range is actually an output for a particular input.
So you meant
Okay.
domain and
Can you
codomain, right?
repeat that? Can you repeat that? Just a second. Can you repeat?
Exactly. I mean that all the values that are present in the range should be an output of at least one input.
Okay, but is that surjective functions?
Okay, Chetan, let us first clarify.
Maybe what do you when you say range, what does it actually mean?
That is what I was saying. Let us make it clear, that what is codomain and domain and
Yeah.
range.
So can
These are three
first
terms,
someone first define what is domain, codomain, and range?
Range.
Just
Yeah.
define.
Just a 1 or 2 minute maneuver. These are very
Domain
base things.
is something from which the function takes in from.
Perfect. So a set of inputs, right? A set of numbers
Yeah.
as in
From which
input.
the inputs are permissible.
Right.
Domain is a
Values which
set of
can be
inputs. Okay.
right. So values which can be inputted, right? A possible set of inputs.
Yeah.
Right?
That is domain. Possible set of inputs. Good.
Right. So what is codomain now?
Possible set of outputs.
Good.
Exactly.
Good.
Yeah, that's correct.
That's really impressive. The way we are, defining it in a very layman terms, that is the impressive thing. Black box, possible set of inputs, possible sets of very, very much, clear. Anyone, watching us can understand this.
Right. What is
Possible set of
range now? What is
now,
range now?
What is range? Yes, correct.
Range is
Range is
a
like
subset
set
of
of
codomain.
Like the
Pardon,
set
pardon?
of
Subset of codomain. Is
Set
that
of codomain.
Range
No,
is the
subset.
actual range of the
Subset.
possible
Like which
outputs.
has
okay,
all
that
the
is actually
outputs.
a property of range.
Which has all
Range
the
will always
possible
be
outputs.
a subset of codomain. But what is the definition of range?
the set of
Means
like
consists
It's
of all the outputs
that
which
are
we get
obtained
after
Chetan, let us go
plugging
one by
in.
one now.
Mhm.
Give everybody a chance. Whoever was, I guess 2-3 people were saying. Let us
Just raise your
deliberate.
hands and we'll call out your names. You unmute yourself, you talk about.
Uh-huh.
Yeah, go ahead, Anshuman.
Range is the set of outputs that we actually obtain after plugging in the inputs.
Perfect. Okay. Yeah, go ahead, Sneha.
yes, I also meant that range is the set of all those outputs which we get after giving an input value.
Perfect. Perfect. So a set of outputs, right? The actual output we are getting. So
Exactly.
codomain is the possible set of outputs and range is actual set of outputs we are getting, right?
I think
So-
someone also mentioned that range would be a subset of codomain, which is correct. But when you ask what is range, maybe that's not the answer we're looking for.
Yeah, yeah. So we can see it that if we are getting some outputs, it should be a part of the all the possible set of outputs. Maybe we are not going to get all the possible set outputs, but we are going to get something that is part of that, right? So that is the basic idea when we say that range is a subset of codomain. That
So-
whatever we are going to get is going to be a part of possible set of outputs.
So everybody got what Maria said. This is very important point she's making. That the definition of function is different than this thing. Both of
Property.
them are true. Both of them are true, but one happens to be a property and one happens to be a definition. Fine. So let us keep that demarcation very much clear in our head. That range is the actual set of outputs. Fine. And it is a kind of corollary, or we can say property, which is a which we get to know after deliberation, that okay, the actual set of output would of course belong to a possible set of outputs. So if anybody is not clear with this thing, this difference, please raise your hand, so that please feel free to ask this question. This is very important. If somebody is not getting clear with this, if somebody thinks that codomain is the range and codomain are same things, please raise your hand. Very important before moving ahead. Very good. Parinit Reddy thinks that codomain and range are same things. Anybody else?
Anyone thinks that?
This
They're
is a
the same
very
thing?
common. This is a very common understanding. Many of us understand this, that codomain and range are same thing. And this is what happens when we think, from basics. We read
That's only the case for surjective function, right?
No, we are not dealing with surjective. Let us delete that first. No, we are not dealing with subjectivity or surjective functions. We are first of all defining some terms related to functions. We are trying to deliberate on the difference between codomain and range. Are they same, or we represent the same thing in two different ways? We give two names to same thing. Panit Reddy thinks two of them are same, isn't it? So how many of us agree with this? That codomain and range are same thing. Nobody. Okay, can somebody explain to Parinit why those two things are different? Anybody? Go ahead. Unmute yourself and just explain why do you think codomain and range are two different things?
I guess maybe some function might be that it is giving, say, inputs over the real line, but not all the the outputs over the real line, but not say all the from a given the given inputs only say lead to particular like some of the say points in the real line are excluded. Like we do not have any input from which we can get those points. And uh, uh,
Maybe we can take an example that makes it clear.
He is saying that
Or someone would like to take some
Praneeth,
example, some
go
very
ahead, Praneeth.
basic example.
Go ahead.
Yeah.
You raised your hand, right?
Yes.
Like you wanted to say something?
Yeah. Suppose if we take an example like a function,
Okay.
and if there is a possibility of getting an output,
Mm-hmm.
then we will somehow get it by taking an input, right?
Yeah, right.
So in that case, I think domain and range may be the same thing.
Hmm.
Because if there is a possibility,
Mm-hmm.
then it
Okay, yeah,
might
it's
we might get.
always a possibility that codomain and range become the same thing, but in essence, are they the same thing?
Yeah, we will come to that as well. So, Sneha was raising her hand as well. Sneha, go ahead.
So, actually, I was thinking of an example to
Mm-hmm.
explain this codomain and range thing.
Mm-hmm. Go ahead.
So, if we take a function, maybe y equals to 2x, and we can consider the domain as real numbers and codomain as real numbers, but the
Mm-hmm.
range will only be the multiples of 2, right?
Range.
Like, if you had said a different domain and codomain, your answer is correct. Like,
What? Can you repeat that?
when we take the domain of real numbers, is it true that you only get multiples of 2?
See, what is your codomain and domain when you say y equals to 2x? I'm more interested in that.
And I'm talking about the real numbers only. Like domain and codomain are the real numbers, but the range will be the multiples of 2 only.
Okay, are you sure?
Under the range.
what
Are
if
you sure? If
what
you're
if we take input
Oh,
one by two?
okay. Yes, I get it. Like if I take integers as domain and codomain, then we will get it.
There you
no,
go.
no.
Yes,
Can you mute
exactly.
everyone? Who is not speaking?
Yeah. Let me do.
Exactly. It was my mistake. I'm sorry.
There's some giggling noise, right?
It's
Okay, fine. Okay, so we were discussing domain and codomain.
yeah, right. So we were discussing domain and codomain. So if your domain is all integers and your codomain is what?
Maybe integers.
Mm-hmm. Correct. So if your domain and codomain both are integers, then is your range equal to what is your range? First, let's answer that question.
This is a very good example.
Multiples of 2
Okay. Yeah. Right.
in
And
integers.
yeah. And now, is this range going to be equal to your codomain?
No.
No. Like the odd numbers are not there.
So now you understand why Maria said that whenever we are defining range, let us do not say that subset of a codomain.
why can't we
This
define?
cannot be the definition of a range.
It's correct. It's a property, but when we define, we can't say it's a subset.
It's a property.
Why can't we like always define codomain to be equal to range? Like for example, why can't we define here like codomain is the integers multiple of 2? Like
Yeah,
somewhat like that.
you can define that. You can define your codomain to be something else. In that case, your range will change as well. Okay, but if your codomain is all the integers, is your range equal to your codomain?
No, in that case it wouldn't be.
Exactly. So it depends on your codomain, right? It depends on your codomain whether your range is going to be equal to codomain or not. It's not
Yeah.
always that your codomain is equal to the range.
Yeah.
Yeah, you
Yeah,
can make
like
both equal,
Sriram's
doesn't make
actually
it always
mentioned
equal.
in the chat that you can make both of them equal, but it's not the case that it's always equal. I guess we can conclude with that.
Correct.
Okay.
So
Now
perfect.
we get to subjective. Yeah.
Now that we
Uh,
have understood what domain, codomain, and range are, can somebody tell me what surjective functions mean? I'm more
I think
interested in
someone
what
said
Sneha
that
said.
in between when we were discussing. If
Yeah,
so,
yes.
like
It was
that same
Sneha.
person can take.
I am more interested in that
Yeah, it was
definition.
Sneha.
Can you
Okay.
repeat that definition, Sneha?
We get all the values for in a surjective function from like the range and codomain should be same in
Right.
that case.
Right.
Yeah.
This time you said the correct definition.
Yes, yes. I'm sorry for the last one.
No. It's okay. It's
Right.
completely fine. We just wanted to see what the definition is, and you gave us a definition. No need to be sorry. So yeah, Sneha said that if your range is equal to the codomain, then that function is a surjective function, right? So in other words, can we say that if you're getting all possible values of output as your actual output, then your function is a surjective function. Can we say that? That if we are getting all the possible values of output as our actual output, our function is surjective. Alternatively, if range equals codomain, our function is surjective. Alternatively, if all the values in codomain in range have some pre-image, all the value in codomain have some pre-image in the domain. All the values in domain, not range, all the values in domain.
All the values in codomain have a unique pre-image in the domain.
Correct. Not range. Range will always have a pre-image in domain, but all the values in
Okay,
codomain.
if you use complicated terms, maybe like I guess everyone understand what's a pre-image, right? Pre-image means something that
Pre-image the
opposite.
input. Pre-image is the input.
Yeah, input. Yeah.
Okay.
Set of
Pre-image
input.
is the input. Set of input. Domain. Values in the domain. Values in the domain. And also surjective functions are also known as onto functions. Okay. Okay. Onto. Okay. Janendra votes for onto.
Yeah,
We'll
that's
use
actually a
onto.
really good way to remember. Like range is spread onto the codomain. Range
Right.
is fully spread across the codomain, like onto the codomain, maybe.
Right.
Yeah, another easy way to think about.
Nothing is left behind.
Yeah. So now, do we agree on what surjective or sorry, my bad, onto functions are?
So one caveat here.
Pre-image and domain are same. Pre-images are values in the domain. Pre-images are the set of inputs.
Okay,
When
Chetan, I'll ask one question. Fine. This will make us things clear for everybody. Fine. The question is, am I audible?
Yes, Vishal, you're audible.
So my question is, we discussed that every element of codomain will have some pre-image. Fine. Everybody agrees with me. This is what we defined onto function to be. So does this mean that all of the elements of pre-image are mapped to codomain? Anybody?
Not necessarily, I guess. I mean, we have an element for every like every element in codomain. We have a pre-image, but there might be
There might be some elements.
Could there be some like elements in the domain that are not getting mapped to something?
Good question. Good question.
to any codomain, any
Okay,
element
good
in the
question.
codomain.
So you're
Yeah.
saying that could there be some values in the domain that are not mapped to anything, right?
Yeah.
Right, good question. So can anyone answer if we have a function that's not mapping an input to some output in the domain, would that even be a function or not?
Could you kindly repeat?
What is the okay, for every input, if we are not getting an output, for every input in the domain, if we are not getting an output,
Hmm.
would we consider that function as a function?
No, it's not a function.
I guess, yeah, that would not
Bingo.
set
So
up the definition of.
right. So the very definition of function is that each value in the domain should get mapped to some
Some
output, some output
in the, yeah.
in the codomain.
So whenever you look at surjective function or onto function,
Then that
always
would be the case.
always go for first, or any function for that sake. First of all, put the touchstone of function. Test whether it is a function or not in first place.
Yeah.
Then
Right.
go to the categorization of it.
Perfect.
Fine. So are we clear that every element in the input is mapped to a codomain, to elements of codomain?
Yeah, in that case.
Perfect. Now we can move on to the
Injective function.
injective functions or
One to
one functions. People would prefer one to one. I know, that's why I asked this question. So yeah, we are moving on to one functions or one functions.
Now, I will mention one thing before we go to one functions. I'll note it down. One understanding the concept of one function is very important to the understanding of matrices.
Right.
So let us be very much attentive while we go through it.
Right. So can anyone tell me what a one function is?
No two inputs have the same output.
Exactly. Perfect definition. So no two inputs will have the same output. If two inputs are having the same output, then the function is not one to one. Are we clear on this? No two inputs would have the same.
A quick corollary. Fine. No two inputs would have the same output. If two inputs of a function are leading to the same output, is it possible that that function is a surjective function? Just a 30-second question. Yes or no, please, somebody.
Okay, is this function one to one function if f of 1 equals to 2 and f of 2 equals to 2? Can anyone tell me?
Is this surjective or not?
It could be. If the range is equal to codomain, then it could be. There's no problem in that.
Is it one to one?
No, I'm not surjective.
It could be surjective.
Okay,
it could be surjective.
Yeah, surjective, right? Not
one.
It's not one to one, but it could be surjective.
Surjective, yeah.
Okay, perfect.
Fine.
Okay, fine.
I guess we have understood what is one to one function.
So no two inputs have the same output is one to one, right? Okay. Can someone tell me what are bijective functions?
No, one second. No, we did not cover one point. So the definition is no two inputs have
the same output.
Fine. No two inputs have same output. So can a one function be a surjective function? No. This should not be a question. Should all one functions be a surjective functions? If
No.
a function is if
Mm.
a function is one function,
Mhm.
does that guarantee that it is also a surjective function?
Yes.
Yeah. He was saying something.
Okay, Rishabh says that every input function does not need to provide output to be a function. Does everybody agree with that?
Sneha says no, it's not necessary.
No, I was saying about that every one function should be an onto or not, like for that. No, it's not necessary that every one function should be a onto function.
Not necessary that every one function is on to function. And what does that mean? Can somebody give it, justify this statement via just one example, and
I
then we will
guess
move ahead.
Let it
I guess we could take the example of logarithm. For that, for every input we have separate outputs, but the codomain might be the R2 plane, but the range is like R plus.
No, we are discussing. See, the focus on this statement, the one written in blue. A function has to be 1, 1. If a function is 1, 1, does it guarantee that it is on 2? The answer
Yeah.
we got is not necessarily. So you have to
Before,
justify
like,
it via an
what's the
example.
necessary thing we need to know before we ask the question if a function is 1, 1 or onto?
What's the code and domain?
What's the necessary thing we need to do? Before that, there's one question we should ask, right? Like, we should ask what the domain and the codomain
Codomain
are.
yes.
Because when you define it in different domains and codomain, it can be different.
So what we must do, quickly, whenever we see a function, what we must do quickly, write these three things, these three entities: domain, codomain, and range.
Can someone please define onto first?
It was for every element, like
I
range
think,
equal to codomain.
I don't remember who, but someone said that it spreads onto. That was an easy way to remember it. In case you get confused.
Range spreads into the codomain.
Yeah, okay, yeah.
Okay, this was just, 30 to 45 seconds stop. Let us not stay here for long. Just give an example and move ahead to this, to justify this. If a function is 1, 1, does it guarantee that it is also on 2? If yes, give it a
Okay, so before, like,
say it by
okay, so what
example.
was
If
the
not,
question you had to ask before you asked whether it's
Answer
1, 1 or
is no
onto?
for
Like, what's
my
the domain and codomain? Yeah.
Hello.
Yep.
Yeah, for my perspective, it will be not 1, 1. Subjective, it will not be the subjective. If the function is 1, 1, it could not be the possible will be on 2 because for 1, 2, can you scroll up? Hello.
Yep.
Yeah.
Yep.
Yeah. Yeah. The onto definition is that domain and range is have the same, but in inject when you give the injective, its definition is f1 f2 could not be the same. Two have no. Injective has f1 is equal to 2 and f2 is equal to 2. It means that two domain two when we put two value, it gives the same input. It does not satisfy satisfy that the range of codomain is the same. I'm
Can you
clearing.
come again if it's okay?
Hello.
You just repeat what you said. I didn't catch it.
Achha, I'm saying that domain or codomain, it will not mandatory that range and codomain will be equal by defining 1, 1. If the function is 1, 1,
Yeah, for
It is not
1, 1, we
necessary
don't
that
need to consider codomain and range. We just have to check if no two inputs have the same output. Like when we learn 1, 1 function, what's the first example that we're actually introduced to? I guess in most cloud, like some function that you just remember when you think about 1, 1 functions. It's not 1, 1, something. Any example or something that is 1, 1.
I can explain with example also.
Yeah, yeah.
Which is, uh, let's suppose here in left side I have 1, 2, 3. Okay, it's input 1, 2, 3,
Mhm.
and it mapped to output. There is it's a range, a domain, and there is range. Its range is 1, 4, 4.
So 1 maps to 1, 2 maps to
No,
4, 3
1, 4,
maps to 4.
148, 148. Let's suppose 148. Range is 148. And 1 map to 1, 2 map to 4, 3 map to 4. It's onto it's in the injective function, but is not surjective.
I'll be back just a minute.
I guess the two examples that we can take are y equal to x cube and y equal to log x. In case of like y equal to log x, there the function would be 1, 1, but not on 2 if the domain and codomain are defined over R to R. And in case of y equal to x cube, it would be 1, 1 as well as on 2.
Okay, enough of examples. I guess it is very much clear that, okay, there is a set of permutation combinations possible. Now we are going to define what is a bijective function, and that is very obvious, and that we have taken enough examples. Of course, we'll focus on that example where a function is both surjective and
Yeah,
injective, and we call it
it's both 1, 1 and onto, then you call it bijective.
bijective.
So it's both surjective, just remember the terms, surjective and
injective.
Injective, yeah.
So we already discussed
Everyone's
this.
familiar with 1, 1 and onto, but surjective, injective is the. Yeah, I think we can move to the next question, Nishan.
Okay, so next question is, given an example of function, give an example of function f such that function f is from R2 plane to R2 plane. Just any example.
We like when we started the discussion, we actually gave an example for this. So if those who are really attentive might actually get this answer really quickly.
Yep.
The matrix example.
Yeah. What was that's correct. That's actually a function from R2 to R2.
R2 to R2, yeah.
Apart from matrix, anybody? An example? R2 to
think
R2?
example that one person I think told f of x comma y equal to y plus 2x.
Is that from R2 to R2? What is the domain and codomain here?
Domain is R2 for sure.
I told you, whenever you are talking about a function, first of all, make sure that it is a function. Ask this question, that for every input there is some output. So our question, again, let us focus on the question at our hand. Give an example of a function such that, function f such that it is from R2 to R2. We know that matrix happens to be one such function. We are looking,
like, can anyone be more precise? Like we said, matrix is a function. You know that the matrix we discussed is from R2 to R2, but what's the dimension or the size of the matrix that you have to get when you have a function from R2 to R2?
Yep. You have to be very much precise to.
Like maybe, okay, maybe let's not go into that, I guess. Yeah, but this.
That's why I was
Think about,
saying
matrix of what
dimensions?
dimensions?
We'll come to matrices eventually. We'll have a lot of time to talk about dimensions of matrices. Let us focus on the question that there is a function f such that it is a function f from R2 to R2.
Right.
Any example? Somebody. Chetan, who were very much frequent in giving answers.
Yeah,
Maybe call their
yeah.
names. Shreya is saying something. No, Shetty to everyone. Okay, so
Bharat
question is.
Shetty. Okay, so question is given example
correct.
of a function. Yeah, right.
We have one answer in the chat, but if anyone else who wasn't active or who hasn't been responding can also give an example. Someone new, that would also be really great for us.
X comma y is equal to x square comma y square.
Yeah, that's correct.
Fine. So the input is from R2 plane and we get an output on a R2 plane, isn't it?
Since we're discussing matrices, I think this came up in between too, but we didn't go into it. This function that you mentioned, can you represent it as a matrix?
To give this example. Fx,
Just think
y.
about it. This wouldn't have been obvious to me before attending the sessions too.
Somebody had posted in the chat box as well. They asked the same thing. F of x comma y equals to x cube plus y cube equals to 0. They asked whether we can represent that as a system of linear equations. So if you guys can answer this, yeah.
I guess if the goal is to represent it as some like multiplication of two matrices, then yeah, we can represent it as like x0, a 2 cross 2 matrix with x0 0 y multiplied by like xy. But if the goal is like the one of the matrix only have to have like constant values and the other matrix only has to have the variable values, then I guess if using linear variables, it might not be represented.
Good, very good. So given the function fxy is equal to x square comma y square, is this function surjective, injective, or bijective? Somebody.
Guys.
If you want to refer to the definitions, we can scroll up and down. Just ask for it.
I guess it is not one-to-one because, for example, if we plug in some value of x and minus x, for example, f of x comma y and f of minus x comma minus y would give the same output.
Yeah, that's correct.
Then if it is not injective, then it is also not bijective.
Correct.
What about surjective?
Surjective f of x. Like the term x square only takes in like positive values and y square also. So if the codomain is like the whole set of real like R2. However, the range is only the positive values of R2. So I guess it is not surjective also.
So if you think about it geometrically, you have the first 4 quadrants, right? So which quadrant will your output actually be in?
Like for x and f of x and x square, like it would be in the above. It would be in the first
Yeah, correct. It would only be in the first
First
quadrant.
quadrant. Yeah.
So it is not subjective, right?
Yeah.
Yeah, we came to that. Like Anshuman actually said that. Yeah, that was a really good response. Yeah.
Good.
I
This
think
is
we had a
really,
couple of answers in the chat too. Yeah.
really good answer.
Yeah.
So we are moving to next question. Give an example of a very nice function. Now the things start getting interesting. You will just, if you are sleeping till now, I'll ask you to just turn yourself on.
This is like a game of 20 questions. We'll just tell you, you can ask us something like, you give some input, what's the output that you think, we'll give
And you'll have
we'll give you the output and you
you'll
have to
have
guess what the function is.
you'll have to indulge with us for that, because this is not, there is no definition. Have you heard of any function called as a very nice function?
Yeah, nice.
Right.
We are here to define, as I told you, Coder Sci is all about that one day. We are here to start from scratch and discover as we go along. So
Like, but this do you mean by bijective function?
no. Let me restate my question. The question is, first of all, previous question was, give an example of a function f such that function f is from R2 to R2.
Right.
Now, differentiate between these two questions. Your answer should not be same. I'm saying, give an example of a very nice function f such that it is from R2 to R2. I have added very nice to the
Yeah, like
function.
just like Srivini mentioned in the chat, like we just need 2 volunteers. Maybe
Yeah,
people who
yeah,
haven't responded now because we're
we,
just playing a game.
we're going to
Yeah,
play a
nice is
game.
related.
Nobody knows nothing.
Yeah.
Everybody is equal now. The ground is zero, playing ground is zero. You can say anything you feel like saying. Okay.
Participants. We need participants for game to complete. So yeah.
So anybody, the ones who have left till now, would miss this thing, thinking, okay, we are doing redundant things, functions and types of functions and all. Anyways, let us do not go there. Let us focus on a very
the
nice
thing is,
function.
this is not a game of 20 questions. Like as we mentioned, you can tell us, you can say like maybe you want the output for a particular function. We'll think of a function. Let's make it clear. We'll think of a function. You have to guess what the function is, but you can only ask us 2 questions. Like if you give this input, we'll tell you that this is the output, and then you have to guess what the function is. So that's the game. Okay, maybe I'll just go through the because we were going on for so long, because we'll check if anyone's sleeping. We'll just take some random people from the. Okay, so is
very good.
Yadav here?
Okay, if people are sleeping, this is a very weird way of sleeping.
Yeah.
Yeah. So I hope people are not asleep.
I just laughed so that if you are asleep, just you can wake up. I could have laughed silently as well.
Okay, Nagashri, are you here? Venkatesh.
Yes,
Nagashri
yes.
Venkatesh.
Hello,
Yes.
guys.
Okay.
I was off for some time.
Okay.
What all happened?
We discussed the first. We are on the 4th question now.
Okay,
Just the
sure.
basics.
Right.
So somebody, we just discussed that we saw an example of a function f such that it is from R2 to R2. Now, the question at our hand, at our disposal is that give an example of very nice function f from R2 to R2. Somebody, random function.
Let us take like f of x comma y equal x cube comma y cube.
Fine.
No. You tell us an input, we'll tell you an output. Okay. You can ask us the output for 2 inputs, and you'll have to guess what that function is.
What the black box is, yeah.
Yeah,
Okay.
with the black boxes. You can ask us 2 questions.
But that like that input could be satisfied by a number of functions, I guess.
So many functions, yeah.
Right.
Maybe we could say that I guess this could be a clue. I don't know. Like it's going to be a linear function, maybe.
Yeah.
Okay, fine. Let's start.
That reduces it a lot, right?
Linear, I guess, like for f of x comma y, we have like only linear variables in like output.
Yeah, the power of x and y is 1. Yeah.
Okay.
Yep.
Fine. Let's start.
Also, that is the answer. But when somebody asks whether we can represent x cube plus y cube equals to 0 a system of linear equation, I hope you got your answer. We'll come to it later, but that's the answer. What Maria just said. Yeah, go ahead. Okay, continue.
Okay, so let's start. 1, 1 and 1. X is 1,
1
y
and
is
1. Okay, 1 and 1.
output.
Computer G, can you tell us the output?
Use computer G, ChatGPT.
Yeah. Let me.
No, we have our GPT that's smarter than ChatGPT.
Is it me? I'm confused. Oh, is it me? I'm so sorry. I was not ready.
Yeah, no.
Wait, just before that, just the people who are organizing the game, are we going with the first type or the second type?
The first type.
Okay. Okay. F of 1, 1, is it?
It's even doing this. Yeah.
Yeah. Okay, perfect. So we have our output. That's minus 18 and minus
I think
17. That's
Steven is like the computer G now, so he'll give you.
so that is the first output you are going to get. You can ask us another output, but those are the 2 outputs that you'll get, and you'll have to guess what the function is.
Can you tell me the 00 F00?
Yeah. So computer G, can we have the output for 0, 0?
Like
Now, after you see the output, you have to, generalize it and find out what is the function. Now, I guess everybody would have understood
Like
what the
I
game
also
is.
asked this question of 0, 0. Like that was something that came with me. Did it this first time. I also asked this question. Yeah.
This is a really, good set of 2 questions.
Yeah. So we have given you 2 outputs for 2 inputs. Now tell us what the function is. And if you ask us more questions, then we'll change the function.
What will the output of F00?
Just a caveat, you can ask, you can give us another set of inputs, fine. And we will give you another set of outputs. That is okay with us, but we will remove what we have also already given you.
The function will change.
The function will change. You can always ask for 2 inputs. We will tell you 2 outputs. And then afterwards, you have to tell what function that is.
Run all sorts of permutation and combinations. Tell us what the function could be.
This is our first shot. The input is 1, 1. We get minus 18, minus 17. Input to same function is 0, 0. We get minus 25, minus 18. What could that function be?
Now
Anybody?
Now we can get the slope and y is equal to mx plus c.
Y is equal to?
Mx plus c.
Mx plus c.
Okay.
So y is 1 and x is 1.
Is this a function in 2 variables? That's my question.
No. Single variable.
This is a function in 1 variable. For 1 variable, I mean, for 1 input, we are getting 1 output. We have got 2 inputs and 2 outputs.
And it's an interesting game. I would appreciate if we have more participants.
Now it is round 1. We have got stats for round 1. Let us deliberate on possible function. Everybody, this is open to everybody, not the ones who have suggested. inputs and they have been given outputs for everybody.
Can I try?
Sure, why not?
Yeah.
Okay, so based on the first one, we can see that the input is 1/2,
Input is
one row by two columns, and the output is also 1/2. So the middle matrix should be like 2/2, so that the 2 and 2 cancel and you get 1/2 as the
Okay, Shreya, what you said is you're actually kind of close, but um, this thing we only said that the functions can be linear. What sort of functions can you actually represent by using a matrix?
Wait 1 second. The functions are linear. I thought we were going with round one.
No. It's not that linear function. We are not talking about linear functions.
Okay.
Okay. Sorry, my bad.
Yeah. It's a little confusing. Sorry.
Let us go by first principle. Keep it very state whatever you think in such a way that it is very much apprehendable to a very layman.
We have our answer though. We have our answer. But yeah, people can go ahead.
Just put it in such a way that everybody
We don't know. We're
understands it.
not gonna reveal if it's correct or not.
We will deliberate on it. So give it a retry. So that is very obvious that we are going to give input of 1 1 and we get output of -18 and -17. Or we give and simultaneously we give it an input of 0 0 and we get -25 -18.
So what what I said, was it wrong?
No, we will of course decide that it is right or wrong first.
Okay.
Okay, I just want to clarify the answer that is on the chat. Rishabh, were you there yesterday?
Yeah,
no, because okay. Okay, I can't hear. Who's talking? Is it Chetan or Rishabh?
Yeah. Can you hear me now? I was saying Rishabh was there in the meeting.
Yes, I was there.
Okay.
Rishabh was there in the meeting.
Okay. How did you get the answer actually? How did you arrive at
a simple linear equation?
Of course, simple linear equation, but can you please deliberate and put inputs and give us output?
Yeah, exactly. I just get the
Okay, let me check. Okay. Guys, no, Rishabh, it's not okay.
I just get we can use a straight line here. Y is equals to mx plus c. So as the output is I took c as -25 here, and y as 0. I found the x that is 7. So I put it as 7x. Okay, actually the slope of x.
Okay, I'll take a new function, guys. Maybe because
better.
maybe let me take a new function. Because
I wasn't aware you were recycling the functions.
Yeah.
I understood that, but I didn't. Yeah.
I was using the same function yesterday. Sorry.
Yeah, I kind of noticed it.
He was there in yesterday's meet, right?
See, guys, our computer is lazy, so don't blame us.
My bad. You can ask me 2 questions and I'll give you 2 answers.
Hello?
Yeah. Go ahead.
I was not there in that session, but I can explain how I approach this question.
Okay, no, we are giving you a new function. Maybe you can explain the function that then.
Yeah,
So,
we'll give you the answer for the same. Swapnil, you can speak. Okay, just 2 minutes before our computer G loads and gives us the right.
Since the second input was 0 0 and the domain was kind of linear.
Yeah,
so
and the second input was 1 1. Yeah.
So that it does not the constant that we are having does not depends on that 0 0 means. So
I understand you are saying
that explains
okay.
25 that is going to be a -25 and -18 definitely there is.
Okay, let's try to see if we're able to generalize for this equation.
And then I added
yeah
for other.
Yeah. Let's try to see if we're able to generalize for this equation. Okay, so can you give me some inputs?
Yeah, tell us inputs. Our computer G will tell you some outputs. Then in return, you'll have to tell us the function. That's the D.
Anyone can go ahead. Just two inputs, two sets of inputs.
1 0
One
and 0
zero.
1.
Okay,
Okay.
1 0 and 0 1. Okay,
Okay.
that's a nice input. Okay.
Wait a minute. There.
While you fetch the function, I'll be back with some water.
So there you have it. Those are the two outputs. Now tell us the function.
I think Swapnil was saying something. If you want, like, can you tell us how to approach it? You said you had an approach.
I have to rethink it about it, this question. I was
Okay,
telling about
yeah.
previous
No
question.
issues. No issues. No
You
issues.
wanted the output for 0 0 and 1 1. That was when you thought of the approach. Okay.
Yeah, it was for previous question.
Yeah, yeah.
Okay, no issues. No issues. Go ahead. You just see. Computer G, is the outputs correct? Are the outputs correct? I just want to know that.
I checked those. So let me reiterate. This function could be any function. I am just taking a function from R2 to R2, and you're trying to find out my function. I'm not saying any property of that function. I'm just saying this function is from R2 to R2, and I'm giving you two inputs, and I'm giving the outputs of those two inputs.
Perfect.
And I wanted to
We
find
have an
my
answer in the chat. I guess.
So if we put our 1 in that function, 2y plus 5, what will that give me? Will it give me 2? Krishna Prajapati.
I guess he meant 5y plus 2. No, sorry.
Okay.
The 2 itself. Can you repeat the question? Okay.
I was saying that if your y is 1, what would your output be? Krishna Prajapati, if your input is 1, then what would your output be if your y is 1?
Since it's taking a while, what could this be? Right? So this is okay. Since the function is defined from R2 to R2, R2 is your domain, right? So what are your set of inputs? Anything can any value of x comma y can be your input, right? So if you find this generalized version of the function, like this is nothing but generalizing the function, right? If I'm given any point x comma y, where does it go to? So let's maybe direct the discussion in that sense.
Yes, I can
People
give.
who actually
I found
answered in the chat could actually explain their approaches. Then
I found the answer.
Okay, Sriram has an answer. Okay. I guess we'll go with the people who replied in the chat. We'll just go through that. Jainendra, like, how did you come up with that answer? Are you there?
Basically, I tried thinking in terms of matrices, what we were doing till now. So we want the function matrix is a function is what we are thinking till now. There's so many days.
I mean, yeah, we weren't discussing matrices now, but yeah,
So
you can.
this can be thought in terms of that as well.
Yeah.
Say we were not discussing. So the reason why I asked to give this input like I like 1 0 and 0 comma 1 is I wanted to see where my I cap and where my J cap is going, where like my matrix, which is a function, where
Yeah, since you were
that
there in the
matrix
right with the
taking my
sessions, and
I.
you know most of the stuff. Yeah.
No, wait. Okay. So Jainendra's answer is saying f of x comma y is equal to. Can someone just tell me the
Yeah, yeah,
answer?
yeah. So the Jayendra's answer was that okay, just a second. So minus x minus y, comma f5x plus 2y. That was one function. Another function that Kashish gave us was f of x comma y equals to minus x minus y, comma minus 3y plus 5, comma minus 3y plus 5.
So okay,
And
can
we have
maybe
another okay,
yeah.
this is the same Anshuman, this is the same function, so we have written it. Yeah.
Okay.
No, go ahead.
So yeah. So
Okay. Anshuman's function is okay. Yeah. Can you write another function, Shriram? Shriram,
yeah.
f of x comma y is minus 1
-1,
comma
5 minus 3y.
5 minus 3y. So the first function is different, not the second one, but the first one function is different.
Okay. So can we just check if everything fits? So minus x minus y for
Yeah,
1
it
comma
does.
0. You've checked, is it? Okay.
Yeah.
Awesome. Okay.
So, like anyone has an idea why we have multiple answers, and can you tell us like which do you think is correct, or do you think all of them are correct, or none of them are correct?
I guess all of them give the same output when these two inputs are obtained. So if we are given only this as information, like for this input we have this output, and for the next input we have that output, then all of the functions satisfy that.
Yeah.
So, Anshuman, like what you said is right. All of these functions actually satisfy. So, how many questions do you think you need to ask us if you want to identify the function uniquely?
I guess first of all I would have to ask, like, is the like f of x comma y, if is that mapped to like linear, like f of x comma y is some, the output is like x square, what is the degree of the variable in the output? If it is linear, then I guess I can assume like the first uh, the first value of the output, let us assume like that ax plus by plus c something, and the second would be similarly dx plus ey plus f, and that would be like 6 something
Yeah,
variables, and
that's precisely correct. Yeah.
Okay, so he
and
says, yeah, okay, so he says he wants to generalize the function as this, right?
yeah,
Comma a2x plus b2y
Guys, I'll be back.
plus c2. Does
Yeah.
everyone agree with this? That if the output only has, the variable, it's not in the second degree or third degree or any
It's the
other
form.
degree. Yeah. So do they agree that this is the general form of the function? Yeah. So how many variables do we have in this function?
6. There are total 6 variables.
Yeah. So we have a1, b1, c1, and a2, b2, c2, right? But okay,
Yeah.
you can think of it like that also. But okay. Actually, 1 second. Just give me a second. A2, b2, c2. Yeah, we have 6 variables. Is it? Yeah. Okay.
So
each okay, so each input gives us how many, what does it give us, what information does it give us? So if I take input this one, it tells me f of 1 0 is going to a1 of, sorry, a1 of 1
Plus
plus
zero.
b2 of 1.
Zero. B2,
My bad.
B1 of 0.
Yeah, just give me a second. b1 of 0 plus c1, right?
Equals to
And
whatever.
yeah, a2 of 1 plus b2 of 1 0
Zero.
plus c2, right? And this gives us just like that, right? Just like that, it gives us two. So yeah, okay. So how would you think of this? How do you think of this? How many equations do you get in? Okay, how many
Like,
equations are you getting on in this?
like for every input, we are getting 2 equations.
Exactly. So if there are 6 variables, how many such inputs do you need?
I guess that would be 3.
Yeah. So if I give you a third function, tell me. So yeah, so you see that, right? If I give you another function, right, which may be 0 0, and I tell you where that goes, right? That will give you 6 different equations, and that will give you 6 variables, right?
Yeah.
So with this 6 equations and 6 variables, you'll be able to solve the question, right? So our game was that I give you only 2, right? So even though there are multiple functions that you can give that satisfy that equation, once I give you the third equation, and obviously only if those equations are different from the other 4 that I've already given you, right? They can't be the same. They can't be like 0 0 and 0 0 again. So if I give you 3 equations, I mean 3 inputs, outputs for 3 inputs, you will be able to find the function, right? Uniquely. You'll be uniquely be able to tell me what the function is, right? Now I'm telling you there are a set of functions defined such that you ask me only 2 questions, and you will be able to tell me what the function is. Okay, so let's go to round 2. If everyone's okay. So for now, the round 1 was just to tell you that I thought of a function, right? And I said the only thing I told you was it was a function that maps from R2 to R2. It can be any function, right? And you asked me for the output of 2 inputs, right? And after that, you tried to tell me the function, but you said you gave me different functions, right? You couldn't exactly map which function I was thinking about. You couldn't find out what was inside the black box exactly.
yeah.
Right? You needed the third function to help you get that because you saw the general form of it and you realized there are 6 variables. And with each input, you're getting 2 equations, right? So you needed 6 equations to make it such that you get the function. Now there are some. Okay, let me take a new page. So this is round 2, right? And whatever I'm gonna call this a nice function, right? Such that it is a function from R2 to R2, but I'm telling you that with just the outputs of 2 inputs, you can pinpoint my you can pinpoint the function, right? So let's maybe do the same thing that we did before, right? Take 2 inputs. I'll tell you the outputs for that inputs, right? And you can ask me 2 questions. They'll ask me where 2 inputs land, and maybe I'll tell you the outputs for that. And with that information, you can try to find the function.
Okay.
So it will be the
1,3.
same.
Yeah.
1,3
Yeah, okay. You want 1, 3? Okay. Now I have to think about it. I have to put it down. I thought people would ask nice easy questions. You always ask the hard question.
Yeah.
Okay. Okay. Now it's and this is your output for your first input. Anyone else? Any other value that you want to know?
0, 0.
You want to know where 0, 0 goes to? 0, 0. Maybe with this you won't be able to solve the answer. Yeah, with this you'll be able to solve the answer. Let's think of, let's see.
0, 0.
It's a
Huh?
constant is 0.
Yeah, this doesn't give you enough information. Okay. You can ask me for any other input as well. 0, 0 doesn't, I mean, doesn't help you solve the two. Yeah, you want 3,
1.
1. Okay. So that will be yeah. Let me just verify everything. Yeah.
If you guys want to, you can tell your approach and we can solve it on the board too.
Yeah.
If like with just two outputs of two inputs, we can pinpoint the function, then I guess also getting the hint from that 0, 0, I guess we can model it like f of x comma y equal to a1x plus b1y and a2x plus b2y.
Yeah.
Yeah. So he's trying to say because I'm telling you that with just the outputs of two inputs, you're able to pinpoint, and also the fact that yes, 0, 0 does go to 0, 0. He was able to generalize these functions as this, right?
Yeah.
Awesome. Okay. So now you just have two equations and two sorry, 4 variables and 4 equations, right? So we all can solve the set of equations. If anyone has solved it. X
Yeah, we have an
minus
answer in the
2y.
chat. X minus 2y, comma 5x plus 3y. Is that the
Exactly. Yeah, the answer is exactly that. Let me write it again. So yeah, f of x comma y is x minus 2y comma 5x plus 3y. Right? So essentially, what happened here? How were you able to? So going ahead with what is it? Anshuman? Anshuman who said that?
Kashish?
Oh, Kashish answered, but Anshuman was telling us
Yeah,
how he arrived at it, right?
yeah, like we had to
Exactly. So
yes.
what is hiding in this function is saying f of 0 goes to 0 is hiding, right? Because I mean the nice function that we are defining over here, right? A property of that nice function can be thought of the fact that when I input 0 comma 0 to it, right, my output is also 0 comma 0. What does this mean? As Anshuman already pointed out, can anyone else point out what it means that 0 comma 0 is being mapped to, I mean, input of 0 comma 0 is giving us
C1 and C2 are 0.
exactly. So there are no constants in our equations, right? C1 is equal to C2 is equal to 0, right? And why does this help? Because when this C1 and C2 are 0, it gives us information about where 0 is being mapped to. So essentially, you know the details of where 0 is going to, right? So you just need the information of two other, inputs for you to get where the output goes, right? That's essentially the point of this game, to make you understand what it means to have. So can anyone define what they see inside this? What is a1x plus b1y maybe? What do they look at it as?
Go ahead, guys. Anyone? Swapnil, Sanjeev, Nagashri, Krishna, Kashish.
Something like dot product of two vectors like a1
Exactly.
b1.
Yeah, you can look at it as the dot product of two vectors, right?
Hmm.
When I take two vectors a1, b1 and xy, right? If I take the dot product of, okay, usually you write it like that. Let me write it like this: a1, b1 and xy, right? When you take the dot product of it, this is nothing but a1x plus b1y, and yeah, this is what it is, right? So
I mean,
yeah,
I think A1, B1 should be written horizontally because we can't multiply.
yeah, I can, but dot products you don't. I mean,
Okay.
dot products is defined even even if the vectors are columns or rows, right? That's okay. Yeah, so okay, you're able to look at it as dot products. That's nice. That's a good intuition to have, because essentially you're able to define the function as a dot product of two vectors. Let's keep that in the back of our minds and maybe go ahead with the next set of questions. So the idea about this game was to help you understand what nice functions are. Here we are defining nice functions as from R2 to R2 as functions which take 0 to 0, right? Which is nothing to say that in their general point, C1 is equal to C2 is equal to 0, right? We don't have any constants that are there in our equation, and we can think of them as dot products, right? Awesome. Is it okay if we go ahead or anything else that has
Yeah,
been
yeah.
pointed out here?
No.
All
I
good.
think that's it. That's it.
Okay.
Yeah. And so now that we have discussed what a nice function is, the next question that we have is, okay, just a second.
Read
Why
it
should
out.
one study such functions, right?
Yeah. Why should one study such functions? Why do we need such functions?
Okay. Maybe one idea is that the constant is only going to shift it by the, it's going to shift by the intercept. It's not going to change the, properties of the function. And slope, all those they never go change. So
Can you
only
repeat? Can
okay,
you repeat, Mission?
the constant will only change the intercept or the, it will just move the function up or down like that. But the properties like, the slope of the function, all that won't change. So
The slope remains same. Okay.
yeah, slope will remain same. So essentially, you still have the properties of the function intact. So you don't care about the function. So you can reduce complexity.
To reduce complexity. Taken. Any other reason why should we study such functions?
Guys, there are 23 people. I'm sure some of you can tell us.
We got 7 answers to our first question about matrices when we wrote, matrix 1, 2, 3, 4, and we asked what does this represent. We got 7 answers. We must at least have half of that, na? Why should one study such functions?
Yeah, I guess just like he pointed out, like constant somehow shift the function. For example, in this case where the C1 and C2 are 0, the functions thus each like x and y is somehow just mapped into some sort of new x and y. Like the origin remains where it is. I guess that might be somehow helpful.
Okay, that's a good idea to think about, right? Origin stays where it is. Yeah, that's what is captured here.
Right.
So the function does not do anything to the origin. It keeps the origin where it is. So
yeah,
maybe it helps us have a reference point, maybe.
Yeah, maybe like
even if the transform function is in a different world, we have the same, our reference point stays the same. Okay.
Yeah.
Okay. Anything else?
Okay. Third point. What's so nice about this function? Why should we study such functions? We remember, every one of us would have done this, make a note of different functions, square root function, logarithmic functions, cube functions, sine functions, cosine functions, their graphs, their domain, their range, their codomain, everything. Here to study nice functions. But what is the motivation behind it? We study sine function and resemble them with waves and all periodic motions. Logarithmic functions have their own applications. Why nice function? We have got 2 answers so far. Can we deliberate on more? I guess you have got a hint on your screen. At least take a hint.
See, our computer is very smart. It'll give you hints as well.
It's all about going easy on your mind. So at least state what you see.
Show us that you can read.
We can rapidly compute or maybe we have three things here. One is input, one is output, one is our system which is doing these changes. If any of this piece is missing, we can get that missing piece with the help of other two pieces.
But that is not that case with every equation. I'm asking,
Right, Chetan.
specifically about, this nice function.
It is
Somebody.
nice in the case like when 0, 0 is 0, 0 is mapping to 0, 0.
Yeah, that's how we have defined it, right?
We took that point now. We wrote it down.
Yeah. So in that
Okay.
case, calculations are really easy in that case. Otherwise, it's really complex.
Complex to reduce complexity.
Yeah.
Okay.
Okay, so actually, vectors can be represented if you take 0, 0 as, reference point.
We have another reason, that is matrices are easy for computers to solve. As for us, solving it is a traditional method or using matrix as function might not be easy. Yeah, that's right.
Okay, it was written in chat.
Yeah, Rishabh said that.
Great. Eventually, we have to, shift to computers to solve complex problems or redundant things.
Yep.
Good answer.
Sriram said something about vectors, right?
That is also a very valid point.
Okay. So yeah, when we say reference point stays the same, if the I mean even there might be something else that let's take a function that does not map 0, 0 to 0, 0, right? There might be some other input that maps to 0, 0. So 0, 0 still exists in that world, right?
Yeah, but then your vectors, you can't draw vectors from 0, 0 always, right? Because you're just assuming that 0, 0 maps to 0, 0, then you just draw from there and then you finish it. But if some other value, then you have to find that value and then map from there.
Okay.
So it becomes another headache for you to find that.
Okay. Yeah. That's right. Okay.
Good observation.
But okay. But I mean, I think the best part is whenever you look at any set of equations like these, what is the form of this equation, right? Ax plus by, you usually have plus c is equal to 0, and you can just take c to the other side, and it will just be ax plus by is equal to minus c, right? So what is this side? Isn't this very similar to what we have? Isn't this a nice function?
Yeah.
Right? Isn't that so? Essentially, you can use that to solve linear equations. Nice functions are there in every linear equation. I mean, in sets of linear equations. That's what I want you to think of, right?
Yeah.
See, mathematics is all about finding patterns, isn't it?
Yeah.
So be very much attentive. Wherever you see a pattern, see a similarity, try correcting them. So you were shown this equation on your screen and you were asked, what similarity do you find between nice functions and these equations? Okay. Vinay has given the answer to this.
Yeah.
So any
Okay.
other reason why you should study such functions? Any other thing which comes to your mind? Anybody? What's so nice after all about nice functions?
This one is very single-handedly
Pardon?
direct link. I guess this one is like single-handedly directly linked. Like I didn't see this ax plus by equal to c. Like for nice functions also we need two inputs to solve it. If you are given like these two equations, that can be like a good reason that nice function could give you the
Exactly. Nishana, are you expecting some answer? Because even I am a little clueless. Or anything else you want to? Because I think we have
Yeah,
covered everything, right?
yeah,
As
right,
he said
right,
also.
right.
Yes.
So the next part of the question is give us a function that satisfy a property that your input should be 2 comma 3 and your output should be 7 comma 4. Give us a function like that. Question number 5.
Note that this function should be defined at all points on R2.
Yeah, yeah, yeah.
I think here is where we had that caveat, right?
So the two vectors will be independent, right?
Yep, yep,
They
yep, yep,
they
yep.
shouldn't be dependent. So by this we
Mhm.
follow
No, no,
the spanning of complete R2.
yeah,
Yeah, yeah.
we were going to come to that when
Yes.
so first define a function such that the input is 2 comma 3 and your output is 7 comma 4. Then we'll come to the next part of this question.
Yeah, yeah, sure, sure.
Then we'll discuss the dependency and independency.
Didn't we have an issue in this question, guys? To the people
Which one?
who were there last night, isn't this the
like
function which? Okay, let me just maybe quickly tell.
yeah, you just like I guess if we even multiply like x gets matched to 7x by 2 and y gets matched to say 4y by 3, then we might be able to obtain that output.
Yeah.
Yeah, just.
No.
Yeah, sure.
No. Sorry. Yeah. Sorry. So
Yeah.
if I just had this condition that 2 3 has to land at 7 4,
Mhm.
right? I could define my function as this, right?
It should be a nice function. It should be a nice function.
Yeah.
Mhm.
So maybe we'll say that it's nice. It's a nice function,
And it should map to all points on R2.
and yeah, domain is R2 and range is R2. Sorry, codomain is R2.
Range is R2. Range is R2.
Yeah, it should be defined for all at all points, right? It okay. It doesn't
Ranges.
really specify range. It talks about this actually, right? It should be defined for every
I
input.
don't
That's what.
remember us completing this question. Did we complete this? Like, or was it just?
No,
Your
we
voice
did.
broke.
Okay,
Sorry,
sorry. Yeah,
I don't remember us completing this question. I mean,
we did.
Yeah.
We did.
yeah.
Can someone go check the sideboard once, maybe?
Oh, yeah. We did. I know. I remember this question.
Okay.
We gave 2, 3 examples of that function, if you guys remember.
Okay. Yeah.
Oh yeah, Namika joined code.
Okay,
Yeah.
yeah,
Can someone give us an example
I
of
think
a nice?
someone already said some example. What was it?
Yeah. Sorry, I think I was focused on something else. Can someone repeat? Whoever was that they told us
7x
about?
by 2, 4y by 3.
Yeah. So 7x by 2,
Yeah, 4y by
4y by 3.
okay.
Okay.
Anything else?
Any other function? Guys, we can have multiple functions. Some other how about 2y plus 0.5x? Does that work?
Yeah, work.
Let me write
Comma.
it left to right. 0.5x plus 2y. Okay.
And y plus 0.5x or 0.5x plus y. 0.5x
Yeah,
plus y.
this
Does
also
that
works.
work?
Absolutely.
Can anyone else come up with another one?
Just one more, maybe. Just one more example.
X plus y plus 2.
X plus y plus
2.
2. Fine.
Oh, okay.
Yeah.
Okay.
Yeah. Okay, maybe we can. Okay, maybe we can keep this to. No, actually, let's not. Let's not keep it. We're going to talk about these nice functions, right? Let's keep it
Yeah.
limited to those. Yeah.
So can we also say
Uh,
2x plus y?
yeah, 2x plus y and minus x plus 2y. Does that work?
X plus y,
Minus
comma.
2x will
Minus
just
x plus 2y. Got it.
minus x plus 2y.
Okay. Okay. Great. Awesome. Okay. So these are all functions that satisfy this, right? You
Right.
can see all these three functions satisfy our three conditions. The first condition is 2, 3 has to go to 7, 4. Let's call this condition. Okay. Condition 1, 2, and 3. Right. Condition 1 is it's a nice function. Condition 2 is such that 2, 3 gets mapped to 7, 4, and condition 3 is it's R2 to R2. So all three functions satisfy this condition.
Okay, so the next thing is that what are the properties of your function? What are the properties that you see in this function?
Yeah, it might be a repetitive from the previous question, what we observed, but
Yep.
maybe make those observations more clear now, right?
Right.
By
Right.
looking at multiple such nice functions.
Basically, it's nice. Yeah, it's a nice.
Right, that's one property.
There is a caveat. Observe it microscopically.
Yeah, microscopically.
We'll just see the beauty of it.
The first one only involves the x and y in each of the points. For example, the x coordinate only has x, and then it depends on x, and the y coordinate only depends on y. Whereas the other two, the x coordinate of the output depends on both x and y, and same for the y coordinate. So
Yeah.
that's one thing that I have taken observe.
Yeah. So there can be functions like these also, okay. And the difference you said was the dependence on what, I mean, the input, right? Okay. First observation that we can make is maybe in all these functions, where does 0, 0 go to?
It goes to the origin itself. Yeah.
0, 0.
Right, this goes to 0, 0. This is the first observation. And any other?
One observation could be like the x coordinate is always like 7 by 2 minus the y coordinate. Or for like x, like for the first set of the code, it might be
This
different for the first, like for the in the output vector, the first value, right? The x coordinate is like 7 by 2 minus 3 by 2 times like the y coordinate.
By 2? What are you trying to say? Sorry.
3 by 2 times the y coordinate. For example, for times the, like for example, in the first 7x plus 2, we don't have any coefficient of y. So that coefficient of y is 0. So the coefficient of x is like 7 by 2.
Yeah.
And for other cases, like whatever the coefficient of y is, we multiply it by 3 by 2 and subtract it from 7 by 2. And like the coefficient of x and y are somehow related in all.
Okay, there is some relation between these. Is it?
Not in these, like for example, 0.5x plus 2y and 2x plus y and 7x by 2.
I think he means to say that it's always like it's like a linear. The one part of it is a linear relationship between x and y.
Dependence. One is dependent on another.
Exactly.
Yeah.
Or independent of another, isn't it?
Yeah. For
Good
example,
observation. There are many nice things about this nice function. This happens to be one of them.
Yep.
You're going in the very right direction. Very much appreciated. Keep going.
How do I write that down actually?
like I guess we could write it down like is equal to like some for some ax plus like that function of a plus of y coefficient is that function of alpha.
Y coefficient is a function of alpha.
Yeah.
But I think that's
I need two
covered when we
numbers.
say it's a nice function, right?
Yeah. Like
wait, okay, I'm a little confused about this. So you're telling me there is some relation between, okay, so here 7 by 2 x plus 0 y can also be the first point, right?
Yeah.
And the second point can be 0x plus 4y by 3. Are you saying there's a relation between this and this?
Yeah.
I mean, if I take any two numbers, there's always a relation, right? I mean, it's like saying there's a relation between 1 and 2. 1 and 2 always have a relation. That 2 is 2 times 1, right? It's, I mean, you're just looking at the scalar values. You can't really say, you're just trying to say two numbers are dependent. Two numbers are always dependent in some way, right?
No,
maybe
not like that. Like we have these three sets of like these two numbers 7 by 2 comma 0. For another function we have this 0.5 and 2, and for the third we have 2 and 1.
Okay. So we have this, okay. So we have such a, okay, so you're looking at the coefficients alone. So you're trying to say it's 0 is 1 and 0 comma 4 by 3 is 1, is it?
Yeah. So like maybe it flows from nice function. Like it was just like by solving them we had that dependence. So,
okay. Okay, let me keep this then. Yeah, this is all okay. So it's like saying there is some, yeah. So maybe I'll, yeah. What is each? When you look at the function 2x plus y comma minus x plus 2y, and now he said focus on the coefficients. It's 2 comma sorry 2 comma 1 and
minus 1 comma 2.
1 comma 2. And there is some
relation
set. No, not that. He's saying, yeah, not a relation, but he's saying this two numbers is able to represent what is happening here. These two numbers are able to represent what is happening here, right? Because we know the input is gonna take the first number of this and the first number of this, and this is gonna take, because we looked at it as dot products, right? Maybe.
Yeah.
We looked at it as dot products. Awesome.
I
That's
guess
a really nice idea.
he's talking about I cap and J cap.
No, he's not talking about ICAP. Okay.
Like
yeah.
One more thing. Because see, we are assuming the fact that these only include operations of addition and subtraction. If they include operations of multiplication, then we can't do it. So yeah, as long as it is I cap and J cap, like as Nishan said, I plus J, then it's fine. If it goes beyond that,
Yeah. So yeah, he's able to say that, okay, I just want to say this, that this is actually able to represent this function somehow.
Yeah.
Maybe we'll keep that in the back of our minds as well, right? That's a very nice
Back of
idea
our
to think. Yeah, yeah. Very
So
nice.
one thing I have one query, like with reference to this the first equation. So is it fine to add like 0y, since we are just writing 3 as a coefficient of y? In that place, I don't think 0y. We can just write it as plus 0. That's fine, because constant is 0 in the nice function. But 0y, will it be applicable over there?
Why not? What is 0 into y? It's 0, right?
Yeah, that is fine. But anyway, you are having the coefficient of. Okay. Yeah. Okay. Go ahead. Yeah. Okay. Sorry. I'm just
Okay.
getting confused answer.
Okay, moving ahead.
Yeah.
Jitendra says that with only one input output mapping, we can get infinite such functions. Right? And then question mark.
Yeah, Janendra. With only one input output mapping, we can get infinite such functions.
Yeah.
And followed by some jargons. We will not deliberate on jargons, of course. That is not a coder size signature. But this is a very good point that he makes. With only one output mapping, we can get infinite such functions. He's talking about generalizing something or finding pattern, I guess. Let us see. Chainendra. Okay, can you just unmute yourself and explain what you just said to everybody?
Right. So basically, we are having only one input output. So the other, in terms of matrices, like we get to know the okay, like where is I cap going, or for example, if we just know where is I cap going, but we don't know where is J cap going. So then with only that one vector, we can make any plane which passes through that vector.
Who knows what is plain at this point of time?
That is there. Yeah.
So let us keep it to basics.
Mhm.
Plain or dependence or independence, we could have used that word. Anyways, we understand what you are trying to say is that with the help of only two inputs, with the help of this 2, 3, and 7, 4, we find function,
keep on.
and with the help of that function, we can find infinite such points which satisfies that function, isn't it?
Okay, yeah, actually, that's another good point. Sorry, maybe I also missed that point.
Are you saying this thing, Janendra, or just I made out something?
Yeah, I think you tried. I mean, what he tried to say is you can find infinite such functions that actually,
satisfies those points.
Yeah, describes this input output combination. But what you were saying is something else. You're saying, okay, if I
find it, if I succeed in finding a function that satisfies this point, then of course we can find many such points which satisfies this function.
Okay then. Now that we have discussed the properties of these functions, can you give us a function that satisfies two conditions? The first condition is f of u plus v, or phi of u plus v is equal to phi of u plus phi of v. And the second condition is phi of u into v is equal to phi of phi of alpha times v is equals to alpha times phi of v. So can you give us a function that follows these two conditions? And the domain is R2 and the codomain is R2.
Okay, I'll reiterate that may have appeared to be a large question, and you may have missed some things. Given a function phi from R2 to R2, I'll read it slowly. given a function phi from R2 to R2, which satisfies the following two conditions. First condition, phi of u plus v is equal to phi of u plus phi of v. Do you understand what is u and v here? Everybody?
Yeah, it's just the input value.
X and y we were talking about, isn't it?
Yeah.
Fine. So x, y is replaced by u and v here. So what it says that given a function phi from R2 to R2, which satisfies the following two conditions, that phi of u plus v, phi of x plus y. Anyways, phi of u plus v is equal to phi of u plus phi of v.
Yeah.
And another property, another
That is-
condition that it must satisfy that phi of alpha times v
is equal to alpha times of phi of v.
Yep.
So yeah, these are the two conditions.
What can you say about such function? First of all, give an example of such function. Then we will deliberate on sub questions. We have question on our screen as well. I was just deliberating on the fact that what is u and v here.
I think this is also something we like examples of these is something we discussed earlier too, because so if you were really paying attention, maybe this won't be that difficult for you.
We are looking at the same problem from different angles. That is all, to give you a hint. X plus y is equal to what? Chittu Raja asks. X plus y is equal to what? We have u and v instead of x and y here. The question is a function.
I guess
No.
f of
u
2x.
plus v. Not that you may take it as x or y, x and y, but the question it is mentioned that it is u plus v. A function is applied to. Chittu Raja says nice function as an example. Anyways, function, we are applying function to u plus v, and the output it is giving is phi of u plus phi of v.
Okay, let's just try to the example that phi of xy equal to x plus y. But in that case, is it a function from R2 to R2? That's also part of our question, right?
Yep.
Maybe Chittaraja can like x plus y is not a function from R2 to R2. Like even what Anshman said, f of x equal to x is also not a function from
R2 to R2.
Yeah. Basically,
First give,
nice, yeah.
First give the example.
Yeah, f of xy equal to x comma y. Yep, I think that works, yeah.
Sorry, I'm back. What's happening?
We were discussing the next like
question number 6.
U plus v equal to phi of u plus phi of v. So one example was f of x comma y equal to
X comma y.
So
x comma y.
Yeah, 1 second. Let me just write the two conditions. So function of x
U plus
plus
v,
sorry, my
u plus
bad.
v, u plus v.
You can take x plus y. It doesn't matter. Just variables,
Yeah,
right?
if you want, we can go with our usual.
If f x plus y is equal to f of
Maybe taking
f of
another
x
u plus v will
plus
be a
f
bit
of y.
less confusing for.
Pardon?
That's my opinion. I think u plus v would make it because when we're defining the function, we're using two variables x and y, right? I mean.
Okay,
Yeah,
okay.
yeah.
Yeah, we can take that.
Okay, and
You're right.
u plus v.
So, Sriram actually said f of x equal to x comma y. So now take any inputs of that function. say obviously like because it's a nice function, 0 0 maps to 0. Then the next thing we should check like u and v are some. Okay, like 1 sec.
Sorry.
So here, u and v are vectors, right? You have to consider them having x and y as their, x coordinate and
Yeah,
y coordinate.
yes.
So, yeah, that will be better.
I guess we
Now
can.
it makes
Yeah.
makes it hard.
So maybe Sriram itself, or if anyone who is not active or who hasn't responded yet could.
We'll
Yeah,
take,
Nagashri,
we will take
Krishna,
three
Sriram,
examples per se. Okay.
Bharat.
We have got one example, fxy is equal to x comma y. We did two such more examples. Somebody
Yeah,
please participate.
yeah.
Let us participate.
Nagashri, Krishna, Bharat. Anshuman is active. Anshuman is participating a lot. But you guys have been on mute. Or maybe you can type in the chat box if you are
Yeah,
in the meeting.
yeah.
Krishna, Nagashri, Janendra,
Okay,
Rishabh.
I was initially confused, like if we gave u plus v like as a single input, however we should have given like a set of inputs, like if the domain is R2, we should have given like x comma y.
Yeah.
Exactly. The u and v are vectors, right? So it matches.
Yeah.
You have x. U has an x component and y component.
Got that.
Maybe we can try out the example f of x y equal to x comma y. So can someone suggest some random inputs for x comma y?
Put 1, 2 and then 3, 4 and then y. I think it was
0, 0 as well.
Yeah, 0, 0, 2.
What did you say v vector was?
3, 4.
Okay. So now we want to see where
F of u plus f plus 3 by 4. Okay, 3, 4, 3, 4 is equal to f of 1, 2 plus f of 3, 4.
Calculate RHS first because it will be easier.
So we will get f of 4, 6 equal to f of 4, 6 is equal to
4,6, yeah. Because I guess it's x comma y, it's not that difficult to see either.
Yeah, exactly. That's why I gave x. Yeah. Again, f of 1, 2 is 1, 2. And then plus, yeah. And then now, 4, 6 equal to 1,
4, 6. F of 4, 6 is equal to 4, 6 only.
Yeah.
And now we do vector addition. 4, 6 happens to be 4, 6. That is the left hand side is equal to right hand side.
True. Okay. So this was
Fine.
Now,
Let us take two more examples. Very
let's
obvious thing.
take but some other numbers, like anyone else can suggest. Someone who has not, let me pick out better guy. Who's Krishna Prajapati? Like, I think you can please suggest some 2 points or so. Or again,
Are we suggesting a new function or a new point?
no. Oh, you want a new function?
a new function, right? So because x comma y is easy, we can see it clearly even if not. But if we try
Okay,
something
a
different,
new
we'll see
function
that.
come. Yeah, okay. I like someone else can tell so that it'd be fun.
Actually, okay. Maybe we'll stop with this also. I think it's quite late. It's already 12. So with this last
Maybe.
example,
Okay.
we can
Okay,
even
fine.
stop.
You can multiply it by any scalar finally, so we know that. Yeah, finally, yeah. Yeah, axiom of linear transformation. Okay, good. Yeah, you can multiply by any scalar and then add. This is any what's that nice function would satisfy this because see
A very important because part, yes. And then we close for the day.
that's the main important point that we have to take. Key takeaway is like any nice function is going to satisfy these two. Was that two conditions?
No, no, no,
The
no, 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 no. You were telling why you said 2x. Why you suggested 2x plus y.
no.
Okay. And comma x minus 3y.
Yeah.
Yeah, I think we forgot to do this, right? We forgot to do of alpha.
Alpha
Yeah,
b.
exactly.
Alpha of 3 vector b should be equal to. Okay, let me write the.
3 into
Written.
f of correct only.
Yeah, let me write the vector. 3 into 3.
1, comma 2.
1, 2. Just take something.
Yeah, 1, 2. We'll go
Plus
to
3 into f of 1, 2. Yeah, so obviously, it's gonna work. Equal to 3 into 1, 2. But sorry, 3, comma 6 equal to 3, comma 6. So, also, Srinivas, can you share these like as a PDF or
yeah, I'll upload it on the drive.
Yeah, no. Is it viewable as a PDF?
Yeah. You
Yeah,
can
you
export
can
it as
export
PDF.
it. Yeah.
Okay.
Okay, let us call it a day.
Yeah.
We'll deliberate on this fxy x comma y
Right.
with the new function next day.
Right.
Yeah.
So we are done for the day, everybody.
Okay, I'll stop recording now.
Yeah.